If 0 represents a normal comet and 10 represents a proven technological craft, 3I Atlas sits solidly in the realm of natural science. But it's no ordinary rock. It's a traveler from beyond our solar system, a visitor older than our planet, and one of the rarest kinds of objects we've ever discovered. This is not a story of speculation or conspiracy. It's the real, evidence-based story of what we know, what we're learning, and what's about to happen next. It began on a quiet night in July 2025. The Atlas survey in Hawaii and Chile, designed to scan the skies for near-Earth asteroids, flagged a faint moving point of light. At first, it looked like just another long-period comet until the orbital solution came back. The numbers didn't make sense. The eccentricity wasn't just high, it was greater than 1, meaning the object wasn't bound to our sun. Its trajectory was hyperbolic, a one-way trip through the solar system. In that moment, astronomers realized they were watching only the third confirmed interstellar object ever detected, after Oumuamua in 2017 and Borisov in 2019. They named it 3I Atlas. 3I for the third interstellar object, and Atlas after the telescope system that found it. From the beginning, it was clear this visitor was special. Its approach vector came from near the constellation links, a direction that placed its origin far beyond any known star system. Working backward, scientists estimated its journey may have begun more than 7 billion years ago, before Earth even existed. It had crossed the galaxy, surviving cosmic radiation, stellar winds, and the gravitational tides of countless stars, before wandering into our neighborhood by pure celestial chance. For months, observatories tracked it as it descended toward the inner solar system. Unlike Oumuamua, which showed no visible coma, 3I Atlas displayed activity almost immediately. It looked and behaved like a true comet, brightening as sunlight struck it, venting carbon dioxide and water vapor and forming a faint tail. This was confirmation that interstellar comets could behave just like our own, icy fragments from distant star systems, following the same physical rules as the ones born here. Hubble's early imaging showed a small, compact nucleus surrounded by a diffuse, teardrop-shaped cloud of dust and gas. From those images, scientists estimated the solid core to be somewhere between 400 meters and 5 or 6 kilometers wide, roughly comparable to an average Earth-made mountain. Its inbound speed was extraordinary, about 61 kilometers per second, nearly 220,000 kilometers per hour, fast enough to travel from the Earth to the Moon in just over an hour. Through the summer and early autumn of 2025, 3I Atlas continued on its predicted path, falling inward toward the Sun. Its closest approach, or perihelion, occurred around October 29, a little inside the orbit of Mars. During that period, the object was temporarily hidden from Earth's direct view, passing behind the Sun from our perspective. It was a crucial time for solar-observing spacecraft, which could monitor it without the glare that blinds Earth-based telescopes. Data from the James Webb Space Telescope, Hubble, and other instruments painted a consistent picture. Spectroscopy indicated a coma rich in carbon dioxide and smaller traces of water and carbon monoxide. These are normal cometary volatiles, but what made them special was where they came from: material forged around another star, carrying the isotopic fingerprints of an alien system. Every molecule measured was a data point in a cosmic chemistry experiment, offering clues to how other planetary systems form and evolve. The brightness of the coma fluctuated slightly as 3I Atlas rotated, hinting at a day length of about 20 hours. That rotation appears unusually stable for an active comet, suggesting its mass is distributed evenly, and its jets are balanced. Observers didn't find the erratic wobbling seen in many comets, which often tumble as they vent gas. Instead, 3I Atlas seemed calm, steady, and graceful, turning once each day with precision that made it easier to model. As the object swung around the Sun, researchers watched for any sign of non-gravitational acceleration, a small push caused by uneven outgassing. These tiny forces are normal. They can nudge a comet slightly off its expected course. In Oumuamua's case, that deviation was what first sparked speculation about alien technology. But with 3I Atlas, so far the evidence points to a modest and entirely natural amount of acceleration. well within the range explained by gas jets and solar radiation pressure. There's no sign of impossible propulsion or sudden speed surges. Every adjustment in its orbit fits the models of cometary behavior that astronomers understand. The color story is also straightforward. Some social media posts claim the comet had turned impossibly blue around perihelion, but that's not supported by official data. In truth, comets can appear bluish in certain filters because of ionized gases, especially carbon monoxide and cyanogen. It's a common optical effect, not a violation of physics. When Hubble and other observatories reanalyze the spectra in December, scientists will be able to confirm how the color changed with distance, another piece of the puzzle for understanding how sunlight transforms interstellar ice. Now all attention turns to the coming weeks. As 3I Atlas moves out from behind the sun, it will gradually become visible again to telescopes on Earth. Early December is when astronomers expect the first new images, with the closest approach to Earth happening on December 19th. Closest still means distant, roughly 1.8 astronomical units, or 270 million kilometers, but that geometry gives us the clearest possible view from our planet. During that period, major observatories around the world will conduct coordinated observation campaigns, tracking its brightness, color, and structure as it recedes. The European Space Agency's JUICE probe, currently on its way toward Jupiter, will also have a chance to capture data during November and December. Because JUICE is much farther from Earth than our telescopes, its data transmission is slower, and those results may not reach Earth until early 2026. When they do, they'll offer a unique perspective, imaging 3I Atlas from outside Earth's orbit, through a different angle of sunlight and shadow. That kind of geometry helps scientists model the three-dimensional structure of the coma and tail with greater accuracy. While we wait, astronomers continue to refine what they can from ground-based instruments. Spectrographs will look for specific molecular bands, water vapor at 557 nanometers, carbon monoxide at 4.7 microns, and carbon dioxide near 4.3 microns. These measurements tell researchers not only what ices are present, but how fast they're escaping and how sunlight shapes their chemistry. Each gas species evaporates at a different temperature, so changes in the emission ratios reveal how energy flows through the object's surface. None of these details suggest anything artificial or threatening. Instead, they hint at a rare opportunity to study the building blocks of another solar system. Every interstellar object that passes through our neighborhood gives us a sample of material that condensed around a different star, an archive of cosmic diversity traveling freely through the galaxy. So what happens after December? 3I Atlas will continue outward, past the orbit of Jupiter in March 2026 and toward interstellar space once again. It will fade rapidly as it cools, losing its coma and returning to darkness. Within a few years, it will be too faint for any telescope to track, slipping silently back into the void between stars. But before it goes, it will have left us with invaluable data. The patterns of outgassing, the isotopic ratios, the precise light curve, and the timing of its jets will all teach scientists how material behaves when it's exposed to billions of years of cosmic radiation. If any subtle anomalies appear, whether in spin, acceleration, or composition, they'll be documented carefully and tested against every natural explanation first. That's what real science looks like. It's not built on viral claims or mysterious headlines. It's built on patient observation, cross-checking, and evidence. And right now, all the evidence tells us that 3I Atlas is behaving exactly like what it appears to be, an interstellar comet, ancient, fascinating, and perfectly natural. Still, the story doesn't lose its wonder. This object may have formed around a star that died long ago. The dust in its tail could carry atoms from worlds that no longer exist, drifting across space for billions of years, only to pass near our own sun by chance. It reminds us that the universe is vast, interconnected, and filled with travelers that bridge the gaps between stars. When December 19th arrives and telescopes around the world turn toward this faint visitor, we'll be watching more than just a point of light. We'll be witnessing history, a piece of another solar system paying a brief visit to ours, a cosmic messenger that crossed unimaginable distances to tell us how common, how fragile, and how connected worlds can be. And then just as quietly as it came, it will leave again, heading back into the deep. Humanity will add another line to the catalog. 3I Atlas, the third interstellar traveler, observed, studied, and remembered, until the next one appears somewhere out there in the endless dark.